We are reading Chapter 26, Section 2, Alternative Energy Resources. As you have learned, many of the fuels used today in renewable resources, including wood. Most people, however, rely on non-renewable fossil fuels for the energy needs. Recently, it has become clear that humans are using up non-renewable fuels at an alarming rate. Even though there are known reserves of fossil fuels around the world, development of such reserves may be too dangerous, too expensive, or too damaging to the environment to be practical. Some experts estimate that petroleum resources may be used up within the next 60 years. Scientists, private companies, and government agencies are all studying renewable alternatives to traditional energy resources. These alternative energy resources include solar energy, wind, water, geothermal energy, nuclear energy, and biomass. Solar energy. Have you ever used a calculator like the one shown in Figure 26.8? This calculator has batteries, but it also has a solar collector that uses the sun's energy to provide power. As you have learned, the sun is the ultimate source of most energy on Earth. The main advantages of solar energy are that it's free and it doesn't cause any kind of pollution. Passive solar heating. Have you ever sat on the vinyl seat of a car that have been in direct sunlight for a few hours? If so, you know that the sun can heat up the inside of a car or a building just by shining through the windows. The sun porch of the house, shown in Figure 26.9, uses the principle to capture sunlight directly and convert it into energy. The sun's energy can also be captured in floors and walls made of concrete, adobe, brick, stone, or tile, which have heat storing capacities. These materials collect solar energy during the daytime and slowly release it during the evening. In some warm climates, these materials also provide enough energy to keep a house warm. Passive solar designs can provide up to 70% of the energy needed to heat a house, as well as up to 60% of the energy needed to cool it. Although a passive solar house can be slightly more expensive to build than a traditional home, the cost of operating such a house is 30 to 40% lower. Active solar heating. Even in the areas that do not receive consistent sunlight, the sun's energy can still be used for heating. Active solar heating systems include collectors such as solar panels and absorb solar energy, and fans or pumps that distribute the energy throughout the house. Solar panels mounted on the roof, as shown in the house in Figure 26.9, have unobstructed exposure to the sun. Heat collected by these solar panels can be used to heat a house directly, or it can be stored for later use in insulated tanks that contain rocks, water, or a heat-absorbing chemical. Solar panels mounted on a roof can heat water up to 65 degrees Celsius, 149 degrees Fahrenheit, which is hot enough to wash dishes and clothing. Solar cookers. Have you ever heard a weather forecaster say that temperatures will be hot enough to cook eggs on the sidewalk? The sun's energy can cook food when it is focused correctly. Solar cookers can be used effectively where fuels are scarce or expansive. Expansive as in countries that have cut down most of their forests. A solar cooker can be as simple as an enclosed box with reflectors to direct the sun's rays inside the box. More sophisticated types of solar cookers, such as the parabolic cooker shown in Figure 26.10, can provide enough heat to boil water by focusing sunlight on one point. When the sun rays are focused in this way, however, they can damage eyesight, and therefore dark glasses must be worn when the solar cookers are used. Photovoltaic cells. All of the uses of solar energy described so far rely on direct sunlight. Using direct sunlight is relatively easy, but energy is also needed during hours of darkness and on cloudy days. On overcast days and in areas that don't get much direct sunlight, solar energy cannot be used directly. In addition, solar energy is difficult to store. An economical and practical method of storing large amounts of solar energy for long periods of time has not yet been developed. If such a method were to be developed, there would be no need for any other energy resources. Until such a method is developed, solar energy is converted into electrical energy by photovoltaic cells, which are thin, transparent wafers made up of layers of boron and phosphorus-enriched silicon. When sunlight falls on a photovoltaic cell, it releases a flow of electrons that creates an electrical current. Although a photovoltaic cell produces only a small amount of electricity, many such cells can be wired together in a panel that provides 30 to 100 watts of power. In the same ways several panels wired together increase the amount of power produced. The electricity produced by photovoltaic cells can be stored in batteries. Photovoltaic cells are reliable, quiet, and typically should last more than 30 years. They can be installed quickly and can be moved easily. Large-scale groups of cell panels can be set up in the desert and in other land areas that are not useful for other purposes. Today, more than 20 public utility companies in the United States use photovoltaic cells in their operations. Power towers are being used to collect solar energy and produce electricity, as shown in Figure 2611. Some scientists estimate that power towers may someday apply 30% of the electric power used worldwide. Energy from water. Are you familiar with the waterfall pictured in Figure 2612? This is Niagara Falls, a waterfall in the Niagara River that straddles the border between the United States and Canada. This waterfall produces electricity for both countries. Water from the falls is diverted into massive turbines. As water falls over the turbines, they turn, producing mechanical energy that drives the generator and produces electrical energy. Energy produced in this way is called hydroelectric power. The power of falling water can also be harnessed to produce electricity when a dam is built across a large river to create a reservoir. The water stored in the reservoir flows through huge pipes at controlled rates and causes turbines to spin and produce electricity. Today, hydroelectric power provides about 20% of the world's electricity and 6% of its total energy. Approximately 10% of the electricity used in the United States is generated by water, while Canada obtains more than 70% of its electricity from this source. Many of the hydroelectric power resources on North America and Europe have already been developed, but in Africa, Latin America, and Asia, many potential sites of hydroelectric power plants have not yet been explored. One advantage of hydroelectric power is that it is non-polluting. Dams built to harness hydroelectric energy provide additional benefits in the form of recreational opportunities, drinking water, flood control, and water for irrigation. Dams also have negative impacts, however. When the reservoirs behind dams fill, they flood large areas and force people to move, destroy wildlife habitats, interrupt migration routes for fish, and change the natural pattern of water flow. This causes sediments to accumulate in the reservoir, steam beds downstream to erode, and water quality to degrade. Energy from the oceans. Ocean water is another potential source of energy. The kinetic energy in waves, which is created primarily by wind, can be used to generate electricity. The barriers built across estuaries or inlets can capture the energy associated with the ebb and flow of tides for use in tidal power plants. One such plant exists in the mouth of Lorraine River in France. While power from moving ocean water is renewable and non-polluting, barriers in the ocean can change the water level and may disrupt coastal and marine ecosystems. Geothermal energy. Most of the energy sources you have studied in this chapter so far come from the sun. However, one energy source used today originates from Earth's own internal heat. Some of the hot springs at Yellowstone National Park in the western United States regularly shoot out geysers, tall fountains of stream mixed with hot water. Old Faithful is one of the best-known geysers in the world. What causes geysers? Water trapped underground in fractures or in porous rock is heated by Earth's internal heat. Some of the water becomes steam. When the heated water and steam escape through cracks in Earth's crust, they explode upwards in specular displays. Energy produced by naturally occurring steam and hot water is called geothermal energy. While other geothermal energy escapes from Earth in such small amounts that it is barely noticeable, large amounts of geothermal energy are released at other surface locations. In these areas, which usually coincide with plate boundaries, geothermal energy can be harnessed to heat homes and businesses, used in power plants to produce electricity, and even used to provide recreational opportunities, as illustrated in Figure 2613. The U.S. Department of Energy estimates that in the geothermal reservoirs in the United States were developed, they could provide up to 30 times as much energy as the country currently uses. Advantages and disadvantages of geothermal energy. One advantage of geothermal energy is that it is abundant and reliable at the sites where it occurs. However, as the water heated by geothermal energy is trapped, cooler water replaces it. To provide continuous power, geothermal energy reservoirs must be managed carefully. For example, in Rotorua, New Zealand, homes are heated with geothermal energy. By the availability of water is decreasing and restrictions are now being placed on its use, geothermal steam is generally pollution-free. But water heated by geothermal energy frequently contains large amounts of water that can clog pipes and pollute surface water. These problems can be eliminated with systems and hold hot water and steam from geothermal reservoirs in closed containers. A greater disadvantage of geothermal energy is that its development can disrupt ecosystems and can cause local air and water pollution. Also, geothermal energy is useful only near sites where it exists because transporting it is not practical. Wind energy. Have you ever seen a windmill? Windmills in the Netherlands have been capturing wind power for humans' use for more than 2,000 years. Today, wind farms, such as the one shown in figure 2614, are replacing the more traditional windmills that farmers once used to pump water from underground wells. The windmills on a wind farm are more properly called wind turbines because they convert the energy of the wind to mechanical energy, which is then used to produce electrical energy. Wind energy increases with the cube of the wind speed. For example, when wind velocity doubles, the wind's capacity to generate power increases 8 times. Most of the wind farms in the United States are in California. Yet nearby, all the energy needs of the country could be met if wind farms were built in just 3 states that experience consistent steady winds: North Dakota, South Dakota, and Texas. Wind turbines currently provide 3% of the electricity used in Denmark. Experts suggest that wind power could supply more than 10% of the world's electricity by the year 2050. Advantages and disadvantages of wind energy. Wind is virtually unlimited energy resources, favorable sites worldwide. Locations at high altitudes generally produce the strongest, most consistent winds. Another advantage of using wind energy is that wind farms can be built quickly and expanded as needed. They are non-polluting and do not require water for cooling purposes, and the land underneath wind turbines can be used for cattle grazing or other farming activities. As a result, wind energy is one of the least expensive ways to produce electricity. Why isn't wind power used to provide more of the world's electricity? Wind power is economical only in areas with steady winds. When the winds die down, people have to rely on backup systems for power, including traditional fossil fuel burning power plants. Other disadvantages of wind farms are that they are not very attractive and they have been shown to interfere with and even kill migrating birds, as well as birds of prey. Windmills also can be noisy and interfere with radio and television reception. Nuclear energy. As you learn in Chapter 3, atoms lose particles in the process of radioactive decay. One process by which atomic particles are given off is called nuclear fusion. Nuclear fusion is a process in which a heavy nucleus, mass number greater than 200, divides to form smaller nuclei in 1 or 2 neutrons. This process releases a large amount of energy. Radioactive elements consist of atoms that have a natural tendency to undergo nuclear fusion. Uranium is one such radioactive element that is commonly used in the production of nuclear energy. Nuclear energy is one other energy source that does not come directly from the sun. In the late 1950s, power companies in the United States began developing nuclear power plants because scientists suggest that nuclear power could produce electricity at a much lower cost than coal and other types of fossil fuels. Another advantage was that nuclear power plants did not produce carbon dioxide or any other greenhouse gases. After 50 years of development, however, 424 nuclear reactors in 25 countries currently are producing only 17% of the world's electricity. Construction of new nuclear power plants in Europe have come to a halt, and no new nuclear plants have been built in the United States since 1978. What happened to the promise of nuclear power? Poor management, high operating costs, poor reactor designs, and public concerns about safety and disposal of radioactive waste contributed to the decline of nuclear power. In addition, nuclear accidents such as those at 3 Mile Island, shown in figure 2615, and at Chernobyl, Ukraine, Shablin, Ukraine, in 1986 alerted people worldwide about the hazards of nuclear power plants. Because of its hazards, nuclear power is no longer considered to be the solution to providing for the world's energy needs, although nuclear power plants continue to provide energy in many countries. Biomass. Biomass is a renewable energy resource as long as organisms that provide the biomass are replaced. Biomass fuels include wood, dried field crops, and dried fecal materials from animals. One way to produce biomass fuel is to plant large amounts of rapidly growing plants such as cottonwood trees in biomass plantations. After harvesting these plants can be burned directly, converted into gas, or fermented into alcohol fuel. Bagasse, which is the residue of sugar cane after the juice has been extracted, is another source of biomass that is burned to produce power, as illustrated in Figure 26:16. The burning of biogas of bagasse produces approximately 10% of Hawaii's electricity supply, and thus it eliminates the need for approximately 2.7 million barrels of oil each year. Other types of biomass fuels are produced when bacteria and chemical processes are used to convert solid biomass into gaseous and liquid biofuels, such as biogas, liquid ethanol, and liquid methanol. A disadvantage of biomass fuels is that when they are burned, they release carbon dioxide and particulate matter into the atmosphere. Biomass is the main source of energy for more than half of the world's population. Biogas. Biogas is a mixture of gases that include 50 to 70% methane gas, 30 to 48 carbon dioxide gas. Plant and animal waste can be converted into methane gas in simple containers called digesters by the action of bacteria. In China, more than 8 million biogas digesters are in use in individual households. In a biogas digester, the gas is separated from the solid waste and piped into homes for use as a cooking fuel. The leftover solid waste then can be used as fertilizer on food crops because the high temperatures inside the digester destroy harmful bacteria. Ethanol and methanol. Liquid ethanol is another name for grain alcohol. Ethanol can be made from sugar and grain crops, including sugar cane, sugar beets, sorghum, and corn. Currently, ethanol produced from corn is used in gasoline mixtures around the world. Gasoline mixed with ethanol makes gasol, which can be burned in conventional gasoline engines. The use of gasol can extend gasoline supplies and reduce dependency on foreign petroleum reserves. Ethanol fuels burn more cleanly than pure gasoline. Liquid methanol, which is wood alcohol, is made mostly from natural gas, but it can also be made from wood waste, agricultural waste, sewage, sludge, garbage, or coal. Energy from oil, shale, and tar sand. You have learned that crude oil and natural gas can be found in porous sedimentary rocks. Sometimes other hydrocarbon mixtures become trapped in different types of rocks. For example, oil shale, shown in Figure 26:17, is a fine-grained rock that contains a solid, wavy mixture of hydrocarbon compounds called kurgan. Oil shale can be mixed when crushed and heated until the kurgan vaporizes. The kurgan vapor can then be condensed to form a heavy, slow-flowing, dark brown oil known as shale oil. Shale oil is processed to remove nitrogen, sulfur, and other impurities before it can be sent through pipelines to a refinery. At present, the cost of processing oil shale is higher than the cost of crude oil sold by countries that have abundant oil supplies. Tar sand is a mixture of clay, sand, water, and bitumen, which is a heavy, black, high sulfur oil. Tar sand also can be mined, then heated until the bitumen fluid softens and floats to the top. Bitumen can be purified and upgraded into a type of crude oil. However, the processes of oil shale and tar sand requires large amounts of energy and produces air and water pollution.